So we finally are there. We gotta talk about it. You might not like it, you might like it, you might not care about it, you might care about it, you might have a political opinion on it, you might not have a political opinion on it, you might never think of it again. But it's going to affect you one way or another. So let's just go ahead and dive right into it. We have to look at the formal data we've led up to it all to now behind climate science. The first thing we're going to look at is what's called the Keinging Curve. And the Keinging Curve is the graph of CO2 in the atmosphere that has been measured for a long time and compared to what we call paleoclimates, which paleo means, before now, climate's climate. And we get that by looking at ice cores that we take in different parts of the world. Now in this ice core, you can look at the different concentration of gases through a bunch of different scientific processes. We know that this is accurate because we've taken ice cores from all across the world, compared the data to the same time period, and get pretty similar results. So we know that's probably what's going on. We also take atmospheric measurements now, and we do a lot of these in Hawaii, and we use what's called the Keinging Curve, and that's what's in your notes. We can see that there's been a dramatic rise in CO2 in the last 60, 70 years, but that's on top of the dramatic rise that we already saw. Now, if you're flipping through the notes, and if you're not, whatever, I'll just put it up here, we can see that yes, this has been a cyclical thing. Temperature's gone up, it's gone down, it's gone up, it's gone down, it's gone up, it's gone down. We also see that on this graph that it's mirrored in that CO2 leads temperature. We know this. We see it happening. We see temperature and CO2 being related. Now, what you might not see on first glance, and I'll zoom into it here, is that last little red thing at the end. That's not a mistake. That's what's happening right now. So, yeah, CO2 has gone up and down and up and down, and yeah, we've been at higher levels in the past. That's true. We've very rarely seen CO2 move this much, and when it has, it's never ended well. It is way too high. It is far too fast of a rate to be sustainable as we move to the future. So in class, we're going to go over that day's specific CO2 count, but I'll say that when I started teaching, and that was only about 5 or 6 years ago, the CO2 level was about 400 parts per million. We can sustain 410, 415 or so. It's not ideal. Ideal is probably in the 380 range or so. Look up the CO2 count for today and see if we're at 410 or 400 or 380. Spoiler alert. Why? Why is all this happening? Well, whether you like it or not, and whether you want to buy into it or not, we're the reason that it's doing this. And I don't mean us specifically, I mean people, and all the choices that we make, and all the fossil fuels that we use, and all the products that we make. And I am just as guilty as anyone else. I am not going to have any kind of righteous, I am better than the rest of you. I'm not. I buy a lot of stuff. I use energy myself, and I drive to places and all of that. I'm not better than the rest of you. I'm not going to make it sound like I'm better than the rest of you. However, I have started to watch the choices that I make, and I encourage you to do that too. This is why I had you write that initial report, if you're in honors, on your energy choices around your house or whatever it is you decided to write on. Looking at the graph, and I'll put it up now, you can see that every color that's listed on this graph is a quarter of all fossil fuel usage. Now, a lot of it goes from way back before we started using it up to, about 1967. So that's pre-industrial times, so middle 1800s, up to 1967. That's about 100 years or so. The next quarter goes from 1968 to 1990. We went from 150 years to 1968 to 1990. Then we went from 1991 to 2008. And then we go from 2007 to now. So not only are we using more of them, look how much quicker we're using them. This is not sustainable in the long term. Now, I know a lot of us are going to say, well, what are we going to do instead? How are we going to fix it? I don't have all the answers. No one has all the answers. No one can have all the answers, but that's not the point. The point is we need to address this and we need to take this as the serious concern that it is, because while no one has the answers right now, and if anyone pretends like they do, then they're lying to you, because no one really does, we need to look at what's going to happen when all these changes continue to ramp up. The biggest thing that we need to talk about then is the exponential rate of temperature increase. Now, 1 degree Celsius, 2 degrees Celsius, that's okay. That's, 1.5 to 2.5, 3 degrees Fahrenheit. That's not great, but we can live with that. That's okay. You start hitting 2.5, 3.5, 4 degrees Celsius rise, we're in trouble. Not only is that a pretty quick rate of increase, it's also what we start to call the runaway effect. As Earth heats up, as the atmosphere traps more heat in, it gets hotter faster, which makes it heat up more, which makes it get hotter faster. And eventually we're going to hit what's called a point of no return, in that no matter what choices we make, no matter what energy we use, no matter what food we eat, it doesn't matter. It's happened, it's done, game over. The Earth is going to keep heating up. And this is important because it's going to start affecting how much ice is on the Earth. Now, maybe you don't care because you've never seen a glacier and you don't live near a pole, so why should you care about how much ice is on the Earth? Well, ice is white, and white is really good at reflecting sunlight, which means it bounces that heat back up into the atmosphere and it starts to spread out. If that ice starts melting, we get more ground. Ground isn't as good at reflecting ice, so it starts to absorb more heat. When it starts to absorb more heat, it starts to heat up more, which means we get hotter, which means more ice melts. You see the problem. It's not that any one thing is an issue, it's that it starts to build and build and build. Okay, so maybe you don't care. I'm fine. I'll just wear shorts and a t-shirt and it'll be okay. Well, no, because part of the problem and why we talked about currents is that as the ice starts to melt, it's going to have to go somewhere, and that somewhere is into the ocean. Well, there's two problems with that. If we look, and I specifically asked you about the Gulf Stream and the North Atlantic Current for this reason, if all the ice in the Northern Atlantic where it's cooler starts to melt, it's going to push that cold water into the Northern Atlantic, which is going to push the Gulf Stream and the North Atlantic Current further south, which means Europe is going to start getting colder. There's a whole lot of people that live in Europe that are going to have a problem with that. But you don't care about that either. You don't live in Europe. You don't want to visit Europe. No one you know ever cares about Europe, so why should you care about that? Okay, maybe not the mindset I would take, but I get it. Well, we live in North Carolina, which has a pretty big coastal region, which is not only just where we like to go for vacation, but it's where we get a lot of our money from too for tourism. If you want to go to the coast like it is right now, then you'd like the coastline to be there. If the ice keeps melting, the coastline is not going to look like it's going to look like. And at our current rates, if we don't change anything, then we're going to get 3 meters, which is about 10 feet of sea level rise by 2100. Now, you might not be alive by 2100, but you're going to see the effects that are happening way before that, definitely in your lifespan. So what do we have to do? Well, we got to make changes, and we got to make choices, and we got to make decisions, and they're not going to be fun, they're not going to be easy, but we have to get the whole world in on it. So what do we need to do to get the whole world to agree to something? Try to get your class to agree to something. That's a hard enough task already, and most of you probably already have a similar opinion on things. Get 190, 200 countries to agree on something, each with their own set of goals and ideas and wants and cares, and they don't care about other things, and geopolitics comes into play, and money comes into... You see, it gets a little complicated. So the best thing that we can do when we try to figure all this stuff out is ignore as much politics as we can, ignore as many feelings as we can, and let's just look at the science to figure it out. If we can at least all start the conversation from looking at the science and start from the same place, maybe we can do it. And what we have to do is take all this scientific data and take all these scientific models and these projections and these ideas, and they're not guesses, they're models based on a lot of math and computational skills that kind of give an idea of what the future might look like if we change this or we change that or we do this or we do that or we don't do this or we don't change that. It's not like we just guessed and threw something up on the wall and said, great, hooray, it's done. It's a lot of time and energy and people working on this to make it fit. So we're going to eventually need to talk about the Paris Climate Agreement, the Tokyo Agreement back in the 90s, and what this means moving forward. Some choices were made, some choices were later changed. What does that mean? We'll find out soon.